Well, hello, good morning, good evening, whenever you're watching this video. I am Mr. Eicher. We're going to be looking at the law of cosines in this video and the next video or two. In this particular video, we're going to be seeing where the law of cosines comes from, how to derive the law of cosines. So let's get started. First, we have a diagram, a well-labeled diagram here for you. This is triangle ABC. And opposite of angle capital A is length side A. Opposite of angle capital B, which is this whole angle, would be this whole side, which is B. And we've broken that up into two different lengths. And then opposite of angle C, we have side length C. We've dropped down the altitude, also known as the height of the triangle, right here. And the height is perpendicular to the base. And the point where the height touches this side AC, we'll call it point D. And we've divided this side length, that was the entire side length was length of B. We've divided it into a length of X, which is from here to here basically. And then if the whole thing is B and this part is X, then that leaves this length, which would be the whole length B minus X. So that's our diagram. Now we'll kind of walk through these different steps and I'll show you where the law of cosines comes from. So step one, using the sides of the triangle BCD, which is this triangle over here, BCD, using those sides, write out the Pythagorean Theorem, and then expand the b minus x squared term. So the Pythagorean Theorem would be this leg squared plus this leg squared equals the hypotenuse squared. So let's write that out. We have h squared plus b minus x squared equals the hypotenuse, which is length of a squared. We're told to expand the b minus x squared term, so that would be h squared. When we expand that, we're multiplying b minus x times b minus x. So distribute, we're going to have some like terms. That looks like it's going to be b squared minus 2bx plus x squared equals a squared. I don't see any like terms. We have a h, a b, and a bx term, an x term. So no like terms. Let's just leave it like that and move on to step two. With the other triangle, which is triangle ABD, this triangle ABD, with that triangle, it's also a right triangle. Write the cosine ratio for angle A, so this angle A, and write out the Pythagorean theorem with these side lengths. So let's see, first we have cosine of angle A. Cosine of angle A, here's angle A. Cosine would be adjacent over hypotenuse. The adjacent side is x, and the hypotenuse of the right triangle is c. Now, I'm going to do a little bit of like this in terms of x. So if we multiply both sides by c, we would get c times cosine A equals x. I'm going to keep that. I'm just going to put a box around that, keep that handy. And then also it says write out the Pythagorean theorem. So the Pythagorean theorem would be h squared plus x squared equals c squared. So that's done for step two. We've done the first two steps. Now basically what we're going to do is we're going to merge all these equations together and then find a formula that we could use to find missing side lengths and missing angle measures for a triangle that isn't a right triangle, meaning this triangle, ABC, this triangle does not necessarily have to be a right triangle to be able to find its angle measures and its side lengths. So step three, use the equations you wrote in step two in your equation from step one to substitute all the x's. So we want to get rid of all the x's and get rid of all the h's. The reason why we want to get rid of the x's is because typically with a triangle, you just know this whole length. You don't really know what these x values are. So we're going to want to get rid of these x's from this first equation, make a substitution to get rid of those. And we happen to have an equation here that tells us what x equals. We also want to get rid of the h's because typically in triangles you don't actually know the height of the triangle. You might just know like an angle, or maybe you just know the 3 side lengths. So we'd like a formula that doesn't have an h in it. And this formula we have has an h right here, this h squared part. So let me rewrite this first equation. Let me get this one, and let me rewrite that right here. And we're asked to substitute out all the x's. So we want to get rid of those x's, and we want to get rid of this h right here. So first thing is, let's get rid of this first x right here. And I solved in step 2 to say x equals c times cosine a. So let's write h squared plus b squared minus 2b times parentheses plus x squared equals a squared. And in that parentheses, instead of that x, we're going to substitute what x equals. We're going to write in c times cosine a. C times cosine. Okay, so that's pretty good. The only other thing we're asked to do is get rid of, we have a couple more x's and we have an h to get rid of. So we want to substitute out this guy right here, the h, and we want to get rid of that x squared. Now, conveniently, if you look to step 2, we're told that if we add h squared plus x squared right here, we know exactly what it equals. It equals c squared. So I can take out both of these terms. So I would have a b squared still. I'd have a 2bc cosine a. And in place of these two terms, I'm going to have a c squared. So we'll do plus c squared. Rearranging this a little bit, we get what's called the law of cosines. The law of cosines. I'm just going to put the sides together, and I'm going to start with the a squared. So rewriting this, we would get a squared equals b squared plus c squared. It's kind of nice to start writing it like this because it looks like the Pythagorean theorem, but we just have this part minus 2 times b times c, and then cosine of angle A. So a couple of things to notice about this law of cosines. A couple things to notice, we need a cosine of an angle capital A is here. Notice that the formula begins with the side opposite of that angle that we use. So whatever angle we use, capital A, lowercase a is the side all by itself on the left side of the equation. Also notice that the other sides, b and c, those sides are squared, kind of like the Pythagorean theorem. But also notice that whatever two sides are there, we multiply right here, b times c. So it might help you as you memorize this law of cosines to just remember the Pythagorean theorem, a squared equals b squared plus c squared, and then minus 2b times c, which are the sides right there. And then cosine, it is after all the law of cosines, so it has a cosine in it. Cosine of angle A, where that angle is the angle opposite of that first side we started with. And that is where the law of cosines comes from. In the next video, we will practice using the law of cosines to solve for missing sides and missing angles of non-right triangles. Have a great day. Thanks for watching.